There are two types of physical properties that we care about for these functional groups. And both they are controlled by the number of carbons as well as the hydrogen bonding. So let's start with the first physical property, which is solubility. The solubility is the ability of the compound to be soluble in the solvent. The compound, normally we call it a solute, and the medium that it's dissolved in, we call it a solvent. So for the solubility, when we talk about alcohols or ethers, both, they need to be 5 carbons or less in order to be water soluble. More than that, they are considered water insoluble. So if I look at methanol versus ethanol, all of these are water soluble. Propanol, all of those are water soluble. However, you're going to see that the solubility is going to decrease once I add more carbons in there. So after the pentanol, it takes longer for pentanol to dissolve compared to butanol in water. And as I increase the number of carbons, the solubility is going to decrease. But all of those are considered to be water soluble in there. Okay. Now, all of these alcohols that are 5 carbons or less, these are considered to be liquids. Now, above 6 carbons, so 6 carbons and more, they range between solids or liquids. It depends on the type of the alcohol that you are working with. The other physical property that controls the solubility is the hydrogen bonding. So hydrogen bonding is always used whenever I want to test for solubility. So I need to take into consideration the number of carbons. This is the first thing, and then the presence of the hydrogen bonding. So what's going to determine if the compound is soluble or not is the number of carbons first. If it is 5 carbons or less, then it is going to be water soluble. But to be water soluble, I need the presence of the hydrogen bonding. More than 5 carbons, it is not water soluble, even if I have hydrogen bonding. The rule says that the more hydrogen bonding interactions I have between the solute and the solvent, the more soluble the compound is in the solvent. So let's say, if I give you this question, is the butanol water soluble? The first thing that you would need to figure out, the butanol is going to be my solute, okay? And water is going to be my solvent. You always have to figure out what is your solute, what is your solvent in this case. Just put them above each other like that, and then consider the rule for hydrogen bonding. So for a compound to exhibit hydrogen bonding interaction, then you would need to have in this compound a hydrogen that is connected to an electronegative element, and the electronegative element is oxygen, nitrogen, or fluorine. And this hydrogen needs to bond with an electronegative element. These are the conditions for hydrogen bonding. And same thing, the electronegative element is oxygen, nitrogen, and the fluorine. So these are the hydrogen bonding conditions in there. So let's see if we have them in here. You always start with your solute in there. It doesn't matter. You can pick the hydrogen in your solute or the oxygen in your solute. It really doesn't matter. But I would prefer at the beginning to, because this is how the hydrogen bonding is formed. It's the hydrogen from the solute in there. So I'm just going to pick that. And this hydrogen needs to be connected to an electronegative element. It is. And then this hydrogen is going to interact with an electronegative element of the solvent, which is the oxygen in this case. So this is going to be my hydrogen bonding. And it is not a bond. This is an interaction. And this interaction increases the solubility between the solute and the solvent. So here, yes, I do have hydrogen bonding. This is one condition for solubility. Another condition for solubility is to look at the number of carbons and make sure you don't exceed 5. And here I do have 4 carbons in there. So this one is going to be 5 carbons or less. And it's actually 4 carbons. So yes, the butanol is water soluble. So here, butanol is water soluble. So 2 conditions for solubility: the number of carbons in your solute and the presence of the hydrogen bonding. And those will secure your compound to be water soluble. Let's have an example in there. Heptanol. Is heptanol water soluble? So heptanol is going to be my solute. Water is going to be my solvent. So you always look at your solute over here. So that is going to be my 7 carbon. Heptanol is a 7 carbon in there. So 7 carbons is way more than 5. So this one is a 7 carbon solute. So no, since there is a lot of carbons in your alcohol, then in this case, even though you have hydrogen bonding, see, I have hydrogen bonding in there. So this here is, I do have hydrogen bonding, but the hydrogen bonding is not enough to dissolve the solute in the solvent, because the solute has a lot of carbons in there. So this means that in this case that no, heptanol is not water soluble, and not water soluble due to the number of carbons. So this one is not water soluble. So the presence of hydrogen bonding is very important because it determines 2 physical properties: the solubility and the boiling point. And both, they depend on the hydrogen bonding. So whenever you have hydrogen bonding, your boiling point is going to increase. And whenever you have a hydrogen bonding, your solubility is also going to increase as long as you have 5 carbons or less. More than 5 carbons, the effect of the hydrogen bonding, even if it's present, is going to minimize in there, and the compound is going to be water insoluble. It's going to be hydrophobic because of the more carbons in the chain. So let's have an example. Does propanol exhibit hydrogen bonding with itself? If you have a question similar to that, I would go ahead and draw propanol, 2 molecules in there, because I said it with itself in there. So you have 2 molecules of propanol, and see if you have hydrogen bonding in there between the 2 propanol molecules. So over here, these are the 2 propanol molecules. Just we're gonna pick a hydrogen in one and an oxygen in the other. So you have the condition of hydrogen connected to an electronegative element, and that hydrogen is going to bond with an electronegative element. I have that. So yes, I do have hydrogen bonding in there. So yes, propanol will hydrogen bond with itself. Same thing here. Is ethanol soluble in diethyl ether? So I'm going to go ahead and draw diethyl ether. This means that ethanol is going to be my solute. So pick your solute, and my solvent is going to be my diethyl ether, and put them like that above each other, and go ahead and apply the condition for hydrogen bonding, because I know that I care about the solute, guys. The solute has to have less than 5 carbons in there, not the solvent, the solute. So ethanol, yes, it has 2 carbons in there, so it is going to dissolve. Now, is ethanol soluble in diethyl ether? We have to differentiate between a water solvent and an organic solvent. So what I have here is my ethanol, which is the solute, and my solvent here, which is organic. Now, before in the condition when we said that my alcohol has to be 5 carbons or less, this is to dissolve only in water. Whenever I have an organic solvent like diethyl ether, I don't care about the number of carbons in there. Okay, so pay attention to that. With organic solvent, I don't care about the number of carbons because I am not dissolving it in an aqueous solution. So here, in order to determine the solubility, it's going to solely depend on hydrogen bonding in there. And ethanol has a hydrogen. I can apply the condition for hydrogen bonding that says that hydrogen connected to an electronegative element, and this hydrogen here is going to interact with the oxygen, which is electronegative element. So over here I do have hydrogen bonding in this case. So yes, these are soluble in each other. So they are soluble in each other. Again, we have to differentiate between when the solvent is aqueous and when the solvent is organic. If the solvent is aqueous, then my solute should not exceed 5 carbons. But if the solvent is organic, I don't care about the number of carbons in my solute. Is ether, which is same as diethyl ether, water soluble? So now with the water solubility, I have to make sure that my organic compound does not exceed 5 carbons, and it does not. It's actually 4 carbons in there. So that is going to be my solute, and water is going to be my solvent. So let's apply the rule for solubility. I need to have hydrogen bonding in there for solubility to happen. And actually I do, because I can have my electronegative element. Okay, I'm going to use the hydrogen from the water in this case. So hydrogen connected to the electronegative element needs to bond with an electronegative element. These are the conditions for hydrogen bonding. So I'm going to use the hydrogen from the water, which is the solvent, and that is going to interact with the oxygen of the diethyl ether. So here I do have hydrogen bonding, and the number of carbons here, they are less than 5 carbons in the solute. So this means that yes, ether is water soluble. Let's see, is there any hydrogen bonding in diethyl ether? So just put the diethyl ethers next to each other in there. Is there any hydrogen bonding? Well, no, there is no hydrogen bonding. Now, of course, diethyl ethers are, because it's the same medium, same phase in there. So these are miscible with each other. It's just diethyl ether. But the question is, do we have any hydrogen bonding in there? Well, no, you don't, because there is no hydrogen that is connected to an electronegative element. So there is no hydrogen bonding. So here there is no hydrogen bonding. Now remember what we said about hydrogen bonding and boiling point. Hydrogen bonding increases the boiling point. So if there is no hydrogen bonding, this means that the boiling point is going to decrease. And this explains why diethyl ether is volatile. It boils at a very low temperature because there is no hydrogen bonding.